Okay, here we have section 8.2, Arithmetic Sequences and Partial Sums. In this section, every formula is going to be an arithmetic sequence, which means you're either adding or subtracting the same thing every time. Versus the last section where sometimes we're adding, sometimes subtracting, or multiplying. We didn't really know the pattern. This section, everything is going to be adding. So keep that in mind as we move forward. Alright, so here's our first example of an arithmetic sequence. We have the terms 4, 9, 14, 19, and 24. Our next step is to identify the pattern and how they're either increasing or decreasing, but in general, how are they changing. To do that, you're going to subtract any two consecutive terms. So if I subtract these two terms, then 9 minus 4 is 5, 14 minus 9 is 5, 19 minus 14 is 5, and finally 24 minus 19 is 5. It's important to note that if any one of these had not been 5, then we don't have an arithmetic sequence, but since they all are all 5, then we can say that the common difference is 5. And that is how something is changing, either increasing or decreasing. Alright, so let's see what you guys can do here. Look at these sequences and try and identify if they are increasing or decreasing, what they are increasing or decreasing by, and if that term is the same, then that is a common difference. So try and find the common difference if there is one. Okay, let's see how you guys did. So for our first set, from 7 to 11, we're adding 4. And then from 11 to 15 we're adding 4, and so on. So every time we're adding 4, which means yes, it's arithmetic, and D is equal to 4. The common difference is 4. Looking at our second term, our second sequence, from 2 to negative 3, we're going to go down by 5. And then from negative 3 to negative 8, we go down by 5 again. And finally, one more time, we get to negative 13. So this is, in fact, an arithmetic sequence. And D is negative 5. Now don't get fooled by the fact that arithmetic you would think it's adding. Again, it's adding or subtracting by the same amount. For our next sequence, we are going from 1 to 4, which is adding 3, and then from 4 to 9, which is adding 5. So automatically we can see that these are not the same difference, which means that no, this is not an arithmetic sequence. And last but not least, from 1 to 5 over 4, we are adding 1/4. Then we add 1/4 again to get over 3 over 2. Add 1/4 one more time to get 7 over 4. And finally add 1/4 one last time to get to 2. So yes, this one is arithmetic and the common difference is 1/4. For the last term, it might have been helpful to get everything in a common denominator to make it easier to see the common difference. Or simply use your calculator to do the subtraction and it'll give you a decimal value. Alright, here's our first example. We have a sub n is equal to 150 minus 7 times n. So to find the first 5 terms, you're going to evaluate this function by plugging in 1 through 5 for n. So you have to do this 5 times. Once you've done it 3 times, if you can identify the pattern, you can use that pattern to continue on to find the remaining 2 terms. So go ahead and try the first 5 terms now. Okay, let's see how you did. To find the first term, we're going to be plugging in a 1 for n, which means we get 150 minus 7, resulting in 143. To find the second term, repeat the process by plugging in 2 for n, and we get 136. To find the third term, plug in 3 for n, and we get 129. And at this point, hopefully we identified that we are going down by 7 every time, which means to find our fourth term, subtract 7, and you get 122. And finally, to find our last term, subtract 7 one more time to get 115. Since we have been subtracting 7 every time, we can say that yes, this is arithmetic, and the common difference, let me get this out of the way, the common difference is a negative 7. Let's talk a little bit more about the formula for an arithmetic sequence. So this is your general formula, a sub n is equal to d times n plus c. D we've talked about, it's your common difference. C is a ratio, which is a1 minus d, or your first term minus the common difference. This is the formula that I prefer to use. I find it helpful and fairly easy to use. There's another formula which is a different variation of the arithmetic sequence which you guys might want to use. It is a sub n is equal to a sub 1 plus d times n minus 1. These result to be the same equation, so it doesn't matter which form you use or going forward, but I'm going to be referencing back to my first formula as we go through the chapter. Let's go ahead and apply this formula looking at a set of numbers. So we have our numbers here, 2, 8, 14, 20, and 26. I've gone ahead and identified our first term is 2. The common difference is how you go from one term to the next. So 8 minus 2 is 6, and you want to verify that using some other terms. So let's say 20 minus 14, that's also going to get you 6. And then the last thing we want to do is find C. C is A1 minus D, which in this case is 2 minus 6, giving me negative 4. So now that I have my parameters, I'm concerned with what is D and what is C. I'm going to plug those two things in for my formula, and that's going to give me my final formula of 6 times n minus 4. And there you have it. Alright, so here we have some numbers that we're going to use to find a formula that will help determine your IQ as you get older. We have the first term and we have the common difference. So what is missing here? We are missing C. C is always our A1 minus D, which in this case is 54 minus 7. So we get as our answer 47. Now that I know what C is, I'm going to take that number and D and plug it into my formula. Again, the formula is A sub n is equal to D times n plus C. So plugging in those values, I get 7 times n plus 47. So according to our equation here, since we are adding 47 with years, you should be getting smarter as you get older. Alright guys, it's your turn. So the following formula helps us model Lucky Larry and how much he wins at the casino. Unfortunately, Lucky Larry is not so lucky. As you can see, he's not always winning. He's losing some money. So go ahead and find a formula that we can use to help Lucky Larry predict how much he will win or lose after a certain amount of bets, and maybe we can use it to help him determine if he should keep on betting. Alright, let's go ahead and take a look. So our first term is A1. That's 10. As we go from 10 to 5, so 5 minus 10, we see that he is losing $5 with each bet. So that's going to be your common difference. My last thing is to find C. And we know that C is A1 minus D, which in this case is 10 minus a negative 5, which means that C is going to be a positive 15. So for my formula, we're going to have A sub n is equal to D times n plus C, which in this case is negative 5 times n plus 15. So what this means is he started with $15, but with every bet he's going to be losing $5. So maybe Lucky Larry is not so lucky. Unfortunately, Lucky Larry is back at it again. After his 5th bet, he had won $190, so he's feeling pretty good. After his 10th bet, he won $115. Not as much, but still a profit. Let's go ahead and try and figure out a formula for Lucky Larry to determine how much he will win after each bet. Notice though that this is set up slightly differently because we don't have consecutive terms. We have the 5th term and then some space between and our 10th term. So we're going to follow a specific formula. We're going to be subtracting the terms, so 115 minus 190 divided by 10 minus 5. And once you subtract your terms, you're going to get your common difference. So 115 minus 90 is negative 75. And 10 minus 5 is going to be 5, which gives us negative 15. So Lucky Larry is winning $15 less every turn. Okay, now I need to find my C value. And we're going to do that slightly different. So I'm going to find my C value using my 5th term. I know that the formula is A sub n is equal to D times n plus C. I have my A sub n term, and 5 tells me what n is. So I'm going to plug things in. Give me 190 is equal to negative 15 times 5 plus C. Negative 15 plus 5 is 75. So when I add that to my 190, solving for my C value, I get 265 is equal to C. So I have found C. I know what D is, which means that my equation is going to be, again, A sub n equals D times n plus C, plugging in those values, negative 15 times n plus 265. So maybe Lucky Larry can keep going for a little bit, but eventually he will be losing money And we know that because we have a negative d value, so it is decreasing the amount he wins every time. Alright, not only do we want to be able to generate the terms for a sequence, but we also would like to be able to find the sum of the terms in a sequence. So at the very top we have our equation for the sum of a sequence. N tells me how many terms that I have. A sub 1 is the first term and a sub n is the last term. So we need three things to find the sum. How many terms are we adding together? What's our first term and what's our last term? Below we have an example to kind of help us identify this formula. So we want to find the 50th partial sum of the sequence -6, -2, 2, and 6. Let's identify what we know. The 50th partial sum means that n is going to equal 50. I know what my first term is, it's -6. What I don't know is what a sub n is, or in this case, what is my 50th term. So to find my 50th term, I'm going to have to generate the formula to find terms in the sequence, which means I need to find my a sub n equals d times n plus c equation. And I could then use that to find my 50th term. Alright, I've already established what a sub 1 is. Let's talk about d. So if I go from -6 to -2, then I am adding 4 every time, which means my common difference is 4. To find c, we have -6 minus 4, giving me -10. Which means that my formula is a sub n is equal to 4 times n minus 10. Okay, now I can use it to help me find my 50th term. So I find my 50th term by plugging in a 50 for n. And I get 290. And now that I have all three things, I can go ahead and plug them into my equation. So I know my last term, again I know my first term, and I know I'm finding the sum for 50 terms. Which means the sum for my first 50 terms is going to be 50 over 2 times -6 plus 290. And once you have simplified that, I got as a final answer 7,100. Okay, so here we have Lucky Larry one more time, trying to change his luck. He knows that he won $15 on his first bet, and he won $307 on his 100th bet. The question now is, how much did he win in all? So we have all the things we need here to find the sum of how much Lucky Larry wins with his betting. Go ahead and plug this into the formula, and then check back to see how you guys did. Alright, so we're finding the sum for the first 100 terms, which means we have 100 divided by 2 times 15 plus 307. If I simplify that, that gives me 50 times 322. And when I multiply those two values together, I get 16,100. And we know that he's winning money, so it would be appropriate to put the $sign here. Good job, Lucky Larry. Alright, now we're going to try and put everything together in one problem. So we have a farmer, and he feeds his cattle every day in July. The first day, he feeds them 97 tons of hay, so that's going to be our first term, a sub 1. The second day, he feeds them 97 tons, so that is a sub 2. And on the third day, 91. Alright, that's a sub 3. Question 1. Find the common difference and interpret it. So we're going to subtract the two consecutive terms, 94 minus 97, giving us -3. We're now asked to interpret it. Since that represents the change in how much he's feeding his cattle, we would say that he's feeding them 3 less tons of hay every day. B. Find the amount of hay given on the 25th day. Okay, so now we're going to need our formula. I know what my common difference is. I know what my first term is. I need to find C. And C is going to be 97 minus -3, which is 100, which means that my formula is going to be -3 times n plus 100. If I plug in 25, then I should get 25, which means that by the 25th day, he is only feeding them 25 tons of hay. Apparently, this farmer is either running out of hay or putting his cattle on an extreme diet. Alright, and then our last question is, how much hay is given out in the month of July? Alright, so a quick check of the calendar shows that there are 31 days in July. So I want to find my 31st term. Alright, so I get -3 times 31 plus 100, which gives me -93 plus 100, which will simplify to be 7. Alright, so then to find the sum of those first 31 days, we have 31 divided by 2 times 97 plus 7. And that's going to equal 1,612 tons of hay in 1 month. Okay, so there you have our arithmetic sequences. Go ahead and start your homework.